We usually meet the periodic table for the first time in a classroom. It hangs on a wall, quiet and flat, filled with boxes, letters, and numbers. At first glance, it feels complete, finished, almost boring. But that is the illusion. Because the periodic table is not a chart. It is a story. And not just any story. It is the story of the universe learning how to exist. Long before planets formed, long before stars learned to shine, the universe was simple to the point of emptiness. There were no mountains, no oceans, no chemistry, no life. There was only energy cooling into matter, and matter choosing its first identities. Out of that newborn universe came hydrogen, the lightest and most abundant element, and a smaller amount of helium. That was enough. Everything else would have to wait. The periodic table quietly reveals this truth. The universe did not begin complex. It became complex through time, pressure, and patience. Hydrogen atoms drifted through expanding space until gravity pulled them together. Where matter gathered, stars were born. And inside those stars, the universe began writing new lines into the periodic table. A star is not just a glowing sphere. It is a machine that turns simplicity into meaning. At its core, hydrogen atoms collide with such force that they fuse, forming helium and releasing enormous energy. That energy becomes light, heat, and time measured in billions of years. Every second a star burns, it is rewriting the universe at an atomic level. As stars age, their interiors grow hotter and denser. Helium begins to fuse into carbon, carbon into oxygen, oxygen into neon, magnesium, silicon. Each step adds a new element to the cosmic inventory. Each step takes longer, costs more energy, and brings the star closer to its end. The periodic table reflects this struggle. The heavier the element, the more extreme the conditions required to create it. But the table also reveals a limit. Stars can only go so far. Iron sits near the center of the periodic table like a quiet warning. Fusing iron does not release energy, it consumes it. When a massive star fills its core with iron, fusion stops. Gravity wins. The star collapses. And then, in one of the most violent events the universe allows, it explodes. A supernova is not just destruction. It is transformation at the highest level. In the brief chaos of a dying star, temperatures and pressures rise beyond anything stable matter can survive. Atoms are smashed together, forcing the creation of elements heavier than iron. Gold, silver, uranium, elements that cannot exist without catastrophe. The periodic table carries this history silently. Every heavy element is proof that the universe once tore itself apart to create something new. The gold in technology, the iodine in medicine, the uranium in power plants. None of these could exist without stars dying long before Earth was formed. And that brings the story closer. Because Earth itself is not separate from this process. Our planet formed from debris left behind by ancient stars. The iron in Earth's core, the silicon in its crust, the oxygen in its atmosphere, all were once part of something much larger. The periodic table connects geology to astronomy, planets to supernovas, and life to deep cosmic time. Look at the elements that make up the human body. Oxygen, carbon, hydrogen, nitrogen, calcium, iron. They are ordinary boxes on the periodic table. But their origin is anything but ordinary. Each atom in you was forged in stellar environments billions of years before your birth. You are not borrowing matter from the universe. You are the universe, rearranged. This is one of the most unsettling truths the periodic table reveals. There is no clean boundary between the cosmos and the self. Your breath contains atoms older than the sun. Your blood carries iron born in collapsing stars. Your thoughts are powered by chemistry shaped by forces that existed long before Earth had a name. The structure of the periodic table itself tells another story. Its rows and columns are not designed for convenience. They emerge from the behavior of electrons, the invisible architecture that decides how atoms interact. As atomic numbers increase, electrons arrange themselves into repeating patterns. Those patterns define reactivity, bonding, and stability. The universe prefers order, even when it appears chaotic. This same preference appears everywhere. Spiral galaxies echo atomic orbitals. Planetary systems mirror nuclear structure. Patterns repeat across scales, suggesting that the laws governing atoms are reflections of laws governing everything. The periodic table is not isolated knowledge. It is a small window into a much larger rulebook. Some elements on the table do not last long. They decay, break apart, and disappear. Radioactive elements remind us that matter itself is temporary. Even atoms are not forever. Stability is earned, not guaranteed. The universe experiments constantly, and most experiments fail. The table includes these failures, recorded as short-lived elements that vanish almost as soon as they appear. Humans have added their own entries. Synthetic elements, created in laboratories, exist for fractions of a second. They push against the boundaries of what matter can be. Each one is a question asked directly to nature. How far does the structure of reality allow us to go? The periodic table is still growing, and that growth reflects curiosity as much as discovery. Yet despite all its complexity, the table remains readable. It compresses billions of years into a single page. It turns cosmic history into symbols. It allows us to understand where everything came from without leaving Earth. That may be its greatest power. The periodic table does not tell us why the universe exists, but it tells us how the universe learned to build itself. From the first hydrogen atoms to the chemistry of life, from stellar cores to human cells, the same elements repeat. Nothing is wasted. Nothing is separate. Everything is recycled through time. When you look at the periodic table again, it may still look like boxes and letters. But behind those symbols are exploding stars, collapsing matter, and a universe constantly rewriting itself. It is not a tool for memorization. It is a quiet confession from reality. The universe reveals itself slowly. It does not announce its secrets loudly. Sometimes, it hides them in classrooms, on walls, waiting for someone to realize that the chart in front of them is not about chemistry at all. It is about origin. It is about connection. It is about you. And in that sense, the periodic table is not something we invented. It is something the universe left behind, so we could one day understand where we came from.